Welcome to another episode of GitHub Copilot. Today we will see how Copilot can be used for code review. We have covered one aspect of code review in a previous episode, especially the coding standards. In today's episode, we will look into the speed and performance of the code as part of the code review, how we can review the code, whether it's having the expected performance and optimized implementation. So today also we are going to use the Pluralsight code review checklist. The third aspect, the considering the speed and performance, is the discussion point for today. As per Pluralsight, we will be looking at two aspects. One is whether the code is executing faster. It's aligned to the speed requirements of the code, or is it optimized in terms of using object allocation and the logging constraints and all such aspects. So some of the questions are listed as part of Pluralsight. We will be reusing these questions, also looking at other aspects of the code review in terms of how to improve or whether the code is aligned to the speed and performance aspects. So without further ado, let us move into the code. So I have multiple code pieces here, starting with the first one, performance perf.cs. It's a C# code. Let us see how we can look at the code review from a performance angle. So starting with a string concatenation function, all of you knows that if you have a large number of concatenation, adding a string into a existing using the plus sign is not optimal. It's not a highly performing aspect. So let us see whether Copilot is able to identify that concern and respond back. It's a non-issue from a developer perspective, and how it can be used. How to optimize the performance of my code. So I have selected the string concatenate function and asked Copilot to see how to optimize it. So Copilot suggested that instead of doing this looping and adding the strings, go for a string builder that gives a high input, or the speed of the code execution is faster compared to the string concatenation. It's used the same string object and append. When it comes to string concatenation using plus sign, it uses always new strings and appending it. It takes more time. So it's a non-aspect for any developers. So that's why I have used that as a simple example in the starting, how to optimize my code. Now going to the next one, where I have a list here. There are multiple lists with a for loop and for each. Whether this is having a performance issue. Normal case, when we go for a list manipulation, we use a for and for each for manipulating the list. So let me ask Copilot to see whether it's having any performance issues. Is there any performance issues with my code? So here I am asking Copilot to suggest any kind of issues are there as part of the thing. So it's coming with the multiple issue reportings. Starting with the first one, pre-allocation. So the list is not pre-allocated. There is no size defined. So the allocation will take the maximum capacity memory location. So it's holding the memory, and it's a performance thing. So for optimizing, go for a pre-allocation, and instead of for loop, go for each. So that is how we can optimize better. So these two are replaced with a for each, and there is a initialization of size. So it's not only given the suggestions, it's given the optimized code for me to replace my code. If I look It looks fine for me. I can go ahead and replace the code. Simple click, replacing. Now let me go for the file. So normally file manipulation, it's a simple file path and reading all the text looks fine, and writing to a file I have the path, content and writing the text directly. But when it comes to a concurrency aspect, when I need to execute a number of write operations, whether this particular function is going to support my concurrency requirements. So I am going with a prompt saying that is this having any negative impact in overall system performance when the concurrency of the users is 10,000 or 1 lakh. So let the Copilot identify the concurrency issues. So performance is not standing apart. It deals with the concurrency. It deals with optimized usage of objects, and then it deals with the speed. So here I am looking at the concurrency aspect. If I need to have the good performing code which can support 10,000 concurrent users writing, then I need to have a different implementation in terms of concurrency issues, file IO operations, expensivity, and there are considerations like instead of going with a file, go for a database or queue or caching kind of thing. So let me ask Copilot, I don't want to use any database or anything. So how to improve my performance in a concurrency area? So I'm going with how can I improve the performance of the file in a high concurrency scenario. So I need the exact write operation, not a database replacement, but still it needs to support a high concurrency scenario. So let me see whether Copilot is able to give some kind of suggestions. It's provided the suggestions in terms of queuing, IO operations, batch writing kind of thing, and also a kind of using clause for locking the write operation so that it goes for a async mode of the execution. So it's implemented the async thing, and also it's given me suggestions. It's not really optimizing the code, a suggestion on improving it further by exception handling. So I just selected the suggestion, the prompt suggestion from Copilot, so that it includes the exception as part of the write operation as well. So it's implemented the write operation with an exception handling. It's still replaced here the exception, but if you want to optimize with a string writer kind of thing, I can ask to add the exception on top of this one also. So I'm keeping the exception part apart. This is how you can improve the concurrency aspect. So the code needs to perform highly well, the speed and the optimized approach. In terms of concurrency as well, it needs to execute better when concurrent users are more. Similarly, if you look at the implementation of sorting, searching and the filtering, multiple aspects have many well-known algorithms. So this sort or algorithm may work good with a small array set, but if the array size is very large, so this may not work in a larger array kind of thing. So let me see whether Copilot have any suggestion. Is this the best performance or best array performing array sort algorithm? So there is no specific statement or prompt structure here. You need to ask Copilot what exactly you are looking at. So I am looking at whether there is an alternative approach which can have a better sorting approach. So it's given multiple options. It's given the details also. This version is using bubble sort, which is not for its simplicity. It's simple to implement, but not for its efficiency. It's not so efficient in terms of the length of the array is very high, then the efficiency is varies. So in C#, we have the array.sort. That is a better approach to follow. And if I need a reverse sorting, I can go with the reverse also. So sort, then go for a reverse so that the reverse sorting can be done. So this is a better approach than going with this symbol sort algorithm. So let me go into the next example where I am going for a detailed logging kind of thing, where we have a for loop where inside that we are going to log the message. Most of the time logging will take a considerable amount of time. Here it's actually logging a write line, but normally it logs to a logging system, an external system. So the number of logs should be considered as part of our implementation. Otherwise, the unnecessary logging may cause performance issues. So let me just select the entire code here and go ahead and ask, or I can just go ahead and ask these 3 to 3 methods and ask Copilot whether this is giving me a optimal performance or not. So any performance issues with my code. So either I can use this way, or I can even prompt and specify that any concerns on my logging implementation. So there is a performance issues, it's given the implementation issues. There is an excessive logging, timestamp generation, because we used a stop batch that is not a production ready code. So it's better to avoid this logging issues. So how to fix this? How to fix the logging or whatever it's specified, excessive logging issue reported in above. In is not reported above, it's okay. So it's going to help me with logging issues. It defined a log level and all these details, whatever the logging information requirements is captured after the for loop. It's moved the log message outside the for loop so that the logging will be less expensive than the for loop. Inside the for loop it will log always. That is not required for any kind of information or error or warning case. You need one time logging instead of repeated logging. Now let us go for another one. Here I have a Python code. So another aspect of performance, we discussed about the speed, the different optimal implementation of algorithms using sorting, concurrency using the file management, logging, expensive logging approach. The next one is duplication of code. Here we have an animal class which is implemented into dog and cat, but animal class have a make sound. There is a separate method. So whenever it's required code or a specific sound kind of thing, it needs to invoke that again. And here the duplicate code for creating and making sound of animals. So let me go ahead and ask the Copilot to identify any duplicate is available here. Any duplicate code exists. So duplication is also add performance concerns. It may have impact on the performance. Duplication doesn't mean that you have the same lines of code repeated 2 times or 3 times. In this case, we don't have that repetition, but we are using this one multiple times. Inside this one, we are calling it the different sounds. Instead of that, you can go ahead and invoke this make sound from dog.make sound instead of dog, specifying this redundant code here. So that's a duplication identified. So as a developer or a reviewer, at one side it doesn't looks like any duplicate. It's looks like plain implementation. It looks fine. So get the help of Copilot to identify the implicit duplicates exist in especially a superclass, subclass implementation or an interface implementation kind of scenario. In this case, we are duplicating this print kind of thing because of instead of invoking this make sound, we are again adding this redundant code here. You can replace that with a proper invocation of make sound. So duplication aspect also covered or support is given by the Copilot. Now let us move to the next one, dealing with HTML code. This deals with the last concern in our plural site checklist. If you have noticed that there is a concern deals with multiple API calls and different asset usage kind of thing. So I'm not talking about any of that aspect. I am just asking Copilot to determine whether this HTML code with the scripts. So if you notice how there is an asset adding, this is an issue, and the API calls goes into a multiple calls, that will be another issue. So let me see whether Copilot is able to identify that in my scripting or a JavaScript itself. So I'm going to ask Copilot, what are the performance implications of my code? So simple question, any performance implications in my HTML code? So it's able to identify there is a multiple API request. If I look here, it won't looks there is a multiple API call. There is only one call, but there is a for each where this particular method is getting called. So the API is getting called as part of this for each, indicating that it's called multiple times. So multiple API calls are concerned. And there is a DOM manipulation inside this one because we are using document.createElement and all. And the image loading, that gives the asset manipulation. It's not doing a proper asset manipulation here, image loading. Error handling is missing and no caching. So how to optimize my code? Again, I am going to select the entire code here and asking for optimizing by addressing the multiple API requests. Even though Copilot suggested multiple performance optimization, I am going to address only one aspect, that is the multiple API requests needs to be addressed as part of the new implementation. The remaining things I am fine with this because the code doesn't record any other aspects. So it's going to help me with this multiple API calls. There is a product list. It's replaced with a promise, and it calls the fetch one time with the product IDs, and it's added that into a list. So the explanation gives you the more detail how it's optimized, what kind of optimization it done. So the promise all will send all requests almost simultaneously and process the response once they will be returned. So it's not wait for one request then wait for the next request kind of thing. So it's a multiple API with a excess asset management kind of concerns can be addressed with Copilot. So let us move to the one more sample which clearly explain how to fix the object allocation issues. So I'm going to select only this particular one, or let me just go with the two methods and ask Copilot any object allocations which leads to performance issues. So that is another aspect. There is a object allocation which leads to the performance issue. Whenever you use a plus equal to name, this create a new strings are immutable. So it means new string object is created every time you concatenate the string. So every time one object is getting created, unless it's done a GC for garbage collection at the end properly, these strings are getting accumulated. So the object allocation is not proper. It gives a performance issue. So instead of that, go for a string builder and optimize it. So we will look on one more example as part of this performance one. Let me go for log sample with a prime number here. If I look at this one, it's a simple function, finding the prime number. Almost it looks fine. It start with a 3 and skip even numbers, and everything is optimized kind of thing. So let me see whether any performance issues are here. So I am going ahead and asking Copilot any performance issues with my code. So the Copilot is going to look at this one and gives the detailed recommendation. So this example is mainly for understanding that Copilot is not only finding the issues, it's also giving if your code is already optimized or not. This code is already optimized. There is no need for further optimization, but you can do a small improvement it's specified. That is also explained in detail here. But the first statement, it's shown that it's an optimized code. If you don't want to touch upon this code any further, it's well and good. It's find optimization. Only thing is this inner loop is started by 2. Instead of that, it can start by 3. And there is a plus 2 can be done because there is no need to go with a even number division. It can be with the odd numbers kind of thing. So this optimized code, there is no need to go with a further optimization. Saying that, let us move back to the speed and performance checklist. So we looked at the string concatenation, logging, allocation of object, duplicate code, any kind of concurrency issues, and any kind of optimized assets or multiple API requests. So almost all these questions related to a code review in terms of speed and performance is addressed by Copilot. So wait for our next episode for understanding how to use Copilot for code reviews in other areas. Thank you.